Yo, what up? Is this thing on? Hello, hello? Ooh. How is everyone doing today? Good, I hope. Gonna get a couple things set up while people show up if they decide to. Let's see. Yeah, so I want to mess around with some fault injection today. Something that I messed around with in a course I took a couple years ago, and it was pretty cool. And I've been doing a bit of reading about some fault injection attacks lately. So it's intriguing. I want to learn about it, practice some of it maybe, and see if we can make some tools to do that kind of stuff. Shouldn't be too hard, right? Okie dokie. Let me get some music going. Do, 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 do. And let's see. All right. So what I have planned that I would like to do is I want to use this jumper list. I want to see if I can get the jumper list to kind of function as my automation for controlling the fault injection attacks. Maybe see if we can do some fun stuff with that, at least control some of it. I want to test and see if the response time for switching is fast enough. And if it is, then we can try something like a crowbar attack, I believe. I'll have to pull up some of the papers that I've been reading. Let's see. Alright, so may want to make a new folder. Get the screen going over here. So I've already got a test board. I do want to test a couple of these pins. I think I had UART on this. I haven't messed with this board in a hot minute. But I've got some pins that I want to test and see if I can get UART on, and maybe that'll give us some good feedback for our fault injection tests. Let's see. Let me get started with this. figure out if I can do UART over this thing. I guess I should try it to a known thing and make sure it's actually working first. Let's see. Oh, I actually could have done that. That's fine. Let's see, let's go with these two. No, where'd that USB cable go? So what I've got going on this board right now, what I've been playing with lately, this board right here is a Raspberry Pi 2040 Zero, and I've got what is it, microanalyzer? Logic analyzer for the 2040. So this tool right here. Just let you hook it up to like Pulse View and other logic analyzer tools, and kind of use it as a inexpensive logic analyzer. So that's kind of what I was messing with a couple days ago. So I need to see if I can use this to find some UART off of these two pins that I was talking about just a second ago. Oops, driver is open bench. Let me set this to our ULA. Oops. Scan for devices. There we go. Okay, so we got our logic analyzer. I'm only using pins. What is that? 14? No, wait. 9 and 10. I'm gonna turn off all the others so I don't get all caught up. I think we'll do 8 as well. Oh, and then I need a ground pin. There we go. This will be where do I have that on this guy? Oh yeah, these are the swimming in cables, y'all. Which pin is it? I think it's this bottom one. Can't remember. Yeah. Okay. Just double checking. And where do we want this? An 8, right? So this green one. Okay. You know what? Normally the colors don't really matter, but no, wait, not that one. Sorry. This guy right here. That's going to be our ground. That's pin 8. And it's a mess of wires. Okay, so I've got a lot of these that are just not being used. Get those out of the way. That one. You come over here. Okay. I'll relabel that, and let's do. I still don't fully understand the sampling rates yet. But I'd imagine it's based off of the hertz of the chip that I'm looking at or inspecting, or how many samples you want to get. Let's see. Okay, so nothing. Let's go ahead and turn it on. I need to get this going too. I need to get a power connection set up so that I can control it outside of the device. Let's see. $50 megahertz. What that gives us? Nothing. And so I don't even know if anything was actually running across these pins when I tested them. Oops, why'd I do that? I think last time I messed with this device, I had I found one UART connection, but couldn't really do a whole lot with it. Let's see. Oops. This connection. I'm just going to measure the voltage, see if it changes at all. .3, it's kind of bouncing a little bit, but not a whole lot. And then let's change it to our other port. See what that one's at. Oops. This one's 3, so that one's a bit lower. Oh, you guys can't even see that, can you? So that is the TX port, as per silkscreened, and this is the RX port, as per silkscreened. So I can get my little debugger and try that. I did also want to try doing it through the jumperless, so I think that's something that you can do. Alright, so okay, the magenta one is TX. Guess we don't need this powered at the moment. Where are the docks? Oh my god. So theoretically, I should be able to route these to UART, TX, and RX, right? Or is that TX and RX for the device out? GPIO pins. I guess that's routable GPIO pins of the Raspberry Pi? Hey, what's up? No, I wouldn't say you've missed anything yet. Still trying to figure out where I go first. It's kind of like a large project idea. But I'm going to work on setting up a fault injection lab. And right now I'm messing with this UART port. I want to see if I can get the UART. It's kind of unrelated, but I want to see if I get these UART ports connected to the jumperless and pass through to the one of the interfaces on the host. And then I could use that as a for my testing to see if I'm actually injecting faults into it or not. Kind of a side quest, like everything that I do. Arduino Nano in the header and UART lines connected. Anything on those lines should be passed through to the second serial port that shows up when you plug in your jumperless. You can also set the config option, serial 1, print pass through true, and have it print on both. Huh. So... ls dev tty pm. Is it the second one? The second serial port that shows up. So if I do minicom d, is it is d dev tty acm 3, and then what are those pins that are the pass-through pins? I think it was under here. Schematic. Oh my god. This is the nano header, right? Where's the nano header? It's a, this thing's kind of like a, it's like a garage door opener, IoT garage door opener. Smart Q, I think? Chamberlain Smart Q. Oh, my queue. That's what it is. This thingamabobber. Look at all these happy people with their garage door openers. This thing. Yeah. Control your garage door from anywhere. Are you ready for in-garage delivery? Anyone else think that's kind of scary? Like, what? I don't know. I feel like I'm, out of the loop here, but the whole Amazon let people in your garage or into your house to deliver packages is kind of weird. But that's just me. Okay, I don't know what the hell it's talking about. Pass-through ports. At least I don't see them on here. Arduino text via UART. Async pass-through. Oh, okay. So where is it actually at on this thing? Oops. The shortcuts to connect D0 and D1 to the jumper list UART, TX and RX is A to disconnect. Oh, D0 and D1. Okay, where is that? D0. Oh, it's right there. TX and RX goes to. I guess if I had an Arduino Nano, it'd be a lot easier to do this. Or I'd have like a header, kind of obvious. Alright, well, anyway, I think what I can do is TX, D0 is RX, this is going to be TX. Alright, Okay, so 2 and 1. Two is going to be that one right there, I believe, and then 1 is going to be this one. Who knows, might set something on fire. That would be fun, right? Then, ground connection? Oh, the screen's a little too small for you. Sorry about that. It's a schematic for the jumper list. Looking at the RX and TX header right here. So you can figure out where that connects on the actual jumper list itself. Because what I want to do is pass through the serial from this board to this to my host. Super janky, but I want to mess around with it and see if I get that to work, because if I can, then that can be part of the instrumentation or like introspection for the fault injection lab. So let's go to connect on boot. Connection baud rate. I think if I just do this and plug it in, it should be fine. I may need to move the ground lead all the way over there. I need more jumper cables. I know it's a jumperless breadboard, right? And I'm using all these jumper cables. Here, I'll just use this one. Wait. Oh no, wait. Yeah, okay, that'll work. Hello, kitty cat. I don't know if that's useful throwing it on the same ground like that, if that'll get me what I need, but who knows. Okay, so do I need to enable pass through? I think that's what I need. To pass through. Save that. Alright. Then we do this now. Does it actually do pass through, or do I need to reload the config or something? I think I probably need to reload the config. Oh geez, here we go. Kevin? Gotta update. I'm gonna turn my scope off. Don't need that on at the moment. Then, let's see. Right. Make this a little bit wider, huh? And then what did it say? It was, actually, let's just print the config. Go current config. Function, pass through, connect on boot. I think I need to set that one as well. Gotta reconnect one more time. Making a mess out of my serial devices on the system. Alright, file save. Then I think I can come over here and reload the config. I'll just connect it manually. Oh, disconnected. Yeah, I can't even remember if this gives me UART. It'd probably be smart to test this with something that does known serial out. 1 second. Be right back. Alright, I wonder if I can emulate serial with the flipper 0. Or send some serial commands with it that I can listen to. Because I can't trust that this device is actually outputting serial over those pins. I don't remember. It's been a minute since I've actually messed with this board. So I can't remember if those pins actually had serial over them or not. I remember one of them did. It may have been one of these. I could test those and see what those give me. As far as that's concerned. I need more pins, more jumpers. Okay. Alright, yellow and orange. Okay. Let's do yellow and orange. At this point, I'm just seeing if I can get anything to pass through the jumperless to my host system over that second port. Here we go. So let's go ahead and I'm going to test this with the flipper, because I have a tool where I can just emulate UART commands on this. Start with some known good UART commands. Alright, so UART pins are 13 and 14 on the flipper. Let's get and I'll need one more for ground. Or not. I'm not actually sure that's required for this use case. Oh no, I don't want that one. Let's see. 13 and 14. Actually, I want to clean up some of this crap's in the way. Just here. Get out of the way. Let's see. Where is connected? How does this work, though? I wonder if I can actually see the light change when I send the command over this. Send AT command, send command, hold import? No. Yeah, I don't see D0 and D1 lighting up on the... Could just be using the wrong pins. Alright, how about this? How about I connect these to 29 and 30, and then within the software, I connect those to D0 and D1. I wonder if I can do that. Let's see. $29, D0, right, 30, D1, oops, D1. Set the configs, your pass rate or pass through, print on both. Interesting, you can also send raw commands. These may not even be the right pins for it, but maybe I also need the ground. Let's see. Oh, no way I'm going to be able to prop this up. Oh, there we go. Oh my goodness. Cannot type. Ah, there we go. It actually printed high this time. Okay. All right, so that's actually passing through the UART. That's cool. So that means that I can actually pass through the UART to the jumper list. I'm guessing I can read that serial with the Python as well. Potentially. See the MicroPython API. GPIO. I think this is what we need. Where was it? UART? UART TX and UART RX. Okay, that's interesting. All right, now that we know that works, we can at least plug those in. We can get UART from our devices passed through. I could try that now with this if we want. See if this actually gets me anything. Where's my ground connection? Right here. And this little doohickey, little brown guy. Okay, let's swap those around. And see what that gives us. Nothing? Okay, so maybe those don't actually have anything going across them. That's fine. Let's test these other pins. I want to test these two right here, which I can do with this. For yellow and orange. And I think maybe this header isn't the one that actually gave me some signal last time I was messing with this board. I think it was this header because I remember it being the network chip that I was talking to. But we will see. Alright, still nothing. Let's check this other set of pins over here. If we don't get anything, that's fine. We move on to some other stuff. I think that was the ground. Let me test. Oh no, wait, it tells me, right? No, I thought that one told me. Alright, so I'm just going to test continuity. None of these? Oh, what's going on? Hello? Oh, my probe's not plugged in. Classic. There we go. Alright, now we test this. Yep. Okay, outside pin on the left. And nothing. Okay, that's fine. Swap these around again. Make sure, because I don't know which one is actually the TX or RX. There are ways that you can figure that out, but I find it's just easier to swap it around. Hey, look at that. Cool. Okay. Now I got some junk going across the display. And I do not believe that I have any control in this. So this is what I was talking about earlier. This is kind of like the network chip that's on here. This is the FN-Link 6220N. This little dude. I believe there's probably some AT commands or something that you can send to this, or some sort of serial command, but I don't think it's actually active. Because it's not taking any input. Like, for instance, you know, normally you'd be able to actually communicate with it. We got nothing, so... Isn't the worst thing in the world. There is... Hello, Minicom. What are you doing? You good? I don't know, maybe Minicom is broken. We can try that again. Oh, you know what? I'm such a goober. That wasn't Minicom's fault. I'm not gonna blame Minicom. It was my fault. My keyboard disconnected. Alright, so we'll try this again. We'll plug this in. Then we get a bunch of junk. Look, we can see it's got physical eFuses. Has data HCITPP PHY eFuse. 9E. Oh, that's kind of fun too, as you can see with the jumper list. When I'm actually sending some UART over it, it makes some noise across the line. You can see it flash. So that's cool. You can see that that's actually going across the wire to the device, and it's not doing anything. So, I wonder if there could be like some hidden commands in here, or maybe it's just not even listening. It could be something. But we could do a little bit of research and see if maybe there's even commands that we can send to it or something. Because maybe that's just for monitoring. I don't know. Like maybe this chip is using I2C to talk to it instead of UART. Because we got this one, which is the PIC microcontroller. That's this one over here. Oh, so you guys can't see anything. Yeah, so this chip is the PIC microcontroller. This is the one that we're talking to right now. Alright, so what I wanted to do next, I could write some Python code. Let me actually get some generic Python code going for this stuff. Let's see. I don't know, glitchless? What do we call it? What do we call this thing? Alright, we'll call it glitch test. Where did that go? I don't know. I want that. I want a new folder. Oh, not even a way? No? No way to make a new folder? Alright. Whatever. Put it under Python scripts. Glitch test. And what I think I want to do is, import upper this J. And I want to, let's just set up some scaffolding real quick. So there was a couple of things that Pico, what, glitch? Yeah, the find us Pico glitcher. And some really good examples of fault injection on here, which is very, very nice. So where was it? Here we go. So I want to test this really quick. I think this is going to be the quintessential tool in the tool belt for doing some fault injection. And crowbar glitching is essentially just dropping the voltage on a voltage line to ground very quickly to kind of interrupt the device or interrupt whatever voltage line that device is connected to. Basically drop a bit or flip a bit or corrupt a bit or cause some sort of like branch in code execution. So what I want to do is I want to test and see if we can get the I'm going to remove this really quick. We don't need any of this at the moment. Probably need these wires, but this stuff I'll just flip it around. Flip it around for now. I can use this same board for testing. Get some crap out of the way. And I'm going to set this off to the side. Get out of here. Alright. So let's go over here and we're going to define our crowbar. And so what we're going to need to do is, I don't know if I need a MOSFET for this. A lot of examples show that people use MOSFETs to basically do this switching to cause this dropout because MOSFETs are fast and precise. Let's see, crowbar switching. Is it? I think it was this one. Ross Marks. Yeah, this guy has a very good write-up with very good descriptions on using our MOSFET or using a MOSFET to do this. So effectively what you do is use the MOSFET. The way he describes this is this whole section is AT-tiny on the right-hand side. This is the microcontroller or device under test or the target. This is the glitching circuit over here on the left. And this MOSFET right here is wired in to basically sync all of the current going to this line down to ground. And what that does is it ends up causing a voltage drop it looks similar like this, or at least should look similar to this on a scope. And that voltage drop will actually be responsible for, you know, corrupting stuff in memory, causing branches to fail or to confirm, basically all sorts of weird stuff. That's why it's called glitching. So what we need to do is, I want to test and see if I can use the jumperless breadboard to get a signal that looks kind of like this, to see if we can drop a voltage signal for a short time. You know, how quick we can get it, or how quick it goes, and test that and see if we can use that without a MOSFET. Because I don't really know a whole lot about the jumperless, but it's got some pretty interesting chips in it. So let's see. What are they? CH something and others. CH11 another? I don't know. Can't remember what they're called. There it is. CH446Q. They're designed for switching video signals, so bandwidth is important. I think we might be able to... Oh, that's fun. There's a forum for jumperless. This guy... Ah, Chinese. That doesn't help me a whole lot, unfortunately. I was gonna see if maybe I can figure out what the properties are, how fast it can switch, but I guess we could just test it. So let's see. I want to get this crap out of here. No! There it is. Import time. Alright, so our pins, A, comma, B equals, what are we gonna do? Let's do 59 and 60, right? 59 and 60. And then we can also test it like 59 to ground. Actually, let's do pin A. Pina. A, B. And then that way we can just swap it on the fly. And then let's set a timestamp. Time now. Right. Oh, it is not a oh man. Can I rename this? There we go. No. Set up some timing variables, and then let's do... I know there's a fast switching command too. Let's see. Fast disconnect and fast connect. It skips the LED update. So we can test it before and after that and see what it gives us. Okay, so let's do connect A to B. I'm just nitpicking. Bruh, stop. Okay. No. Here, hold on. Equals time dot now minus 4 or start. Actually, bruh, what the non-tab using. All right. Now I want, bro, what the? Whoa, I'm so mad. Okay, jeez. The IDE kept popping my cursor like a couple spaces over, which is really annoying. Elapsed equals. Oops. There we go. And then we can duplicate this. Hello, kitty. We'll save it. Send it to the board. And then let's just get get some sample stuff going. That's kind of what I had before I started the stream up, but whole mess of wires. Oh my god. So many wires. Right, so this is going to be our negative rail, this is going to be our positive rail. And I'm going to run this at something like, I don't know, we'll do 5 volts. Here we go. And we'll get the scope going. And I'm gonna get another wire for the scope. For the ground. That work? No. Like that, that works. Give me that. And then I think what I want to do is have a simple circuit with this like LED or something wired up, and I think sucker wants to go in. What the hell is wrong with you? Holy crap. Resistor's all bent out of shape. And we're going to stick this right here. And then we need a ground wire. This dude. Cool. So I'll stick him right there. Bro, what is wrong with this breadboard? And then, should light up the light. Oh, if I don't have it backwards. Sucka, sucka. No? What am I doing wrong? What the hell? Oh, I did have it in there wrong. Alright, so the LED is lit up. Get our scope dialed in. I'm gonna move this all the way down. Oops. Oh. Alright, so our maximum is at... We can even set up a button to kind of sync this to ground if we want. Because this is also another mechanism that you can do for voltage glitching, is you can just use a simple button. You don't actually have to have a crazy complex circuit or anything like that, or a crazy setup. You can just use a little button and a wire that goes to ground, and you can drop the voltage on a trace and get it to do something fun. In this case, let's see. I go ahead and I want to move this resistor a little bit. Okay. Then I'm going to take the button. I'm going to stick it right here. I guess that's not really viable. I'll just use another jumper. Who cares? Or another 2 jumpers, I guess. Right, so I got my button right here. One of these is going to go in between, and then the other is going to go to ground. And then if we do that, you can see on the scope, turning our button off, well, not turning it off, but dropping it to ground. Our LED likes it though. I don't know what the hell's up with that. What am I doing? What? Oh, that's why I'm so stupid. Doing it before, like I have no control over the ground of this thing. So the ground actually goes. Circuits are hard. I've got my button ground, right? And that goes to here. Oh, I need positive voltage. Oops. Yeah. Trying to not overcomplicate this with a bunch of wires, but here we go. Okay, so that turns on our light. What we need to do now is we need to short this to ground with our button, like so. Still makes it brighter. What am I missing? Oh, I'm just bypassing the damn resistor. When I do that, that's all I'm doing is I'm just bypassing the resistor. And what this will turn it on when I push the button, right? Boop, 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 boop. Okay. Then, let's see. I need another wire. I need another wire. Hello. This guy. Going to here. Alright, and then let me take this guy, move him to ground. Oops. There we go. Okay. Now we're actually dropping it out. Let's get our probe back on there. Okay. Yeah, if I wire the damn circuit properly. How hard could it be to wire an LED, right? Okay, so that's actually dropping out our circuit. And what I want to do is basically run this over to the jumperless so we can test how fast the jumperless can do it. Actually, real quick, what we can do is we can see what the fall time is. Let's set a trigger, do a single, and then push the button once. And I think that'll give us an idea of how long that actually took. Maybe not. I may have grabbed that wrong. Because it comes down to, is it down there? Yeah. There we go. Yeah, so we can see how long does it actually take. Each of these is 200 nanoseconds. Each of the little tick marks. I think I can measure. Well, if I knew how to use my scope more. It looks like it's actually about 200 nanoseconds from here to here. About 200 nanoseconds, but from the actual, I guess, does it start right here? Because it kind of oscillates. It's all solid doing nothing, and then it starts to wiggle as I push the button, and then fully drops. So you could even call that more, from like here to here to here to here, so that's like what, 800 nanoseconds? Not super fast. It's fast, but it's not super fast. So I wonder if we can do better with the jumper list. If I wire this over into the jumper list and we have the Python run it, basically disconnect this, jump this to ground, then maybe we can get a faster response. But more importantly, it'll be automated. So that's the important part. So even if it's not incredibly fast, what we can do is we can automate it and then hook a MOSFET up to it, and I believe that should make it quicker. It'll make that on and off faster. Alright, so we've got that going. And then I think what I want to do run this, and then I think I can do this is going to be, or is it 29? Wait a minute. Oh yeah, because these aren't on the same ground potential. Let me just connect them to each other because it's going from ground to, okay. Oops, I'm doing that all wrong. I haven't even sent my import statement. Alright. Oh, is that a date time thing? It might be a date time. Who's it? CPU clocks, but it doesn't have to be CPU clock, blah blah blah. Ticks. Might be better for measuring that. Number of seconds as an integer. Very fine benchmarking or very tight real-time loops. Okay. I do think I want that though, similar to TixMS and TixUS. Let's try TixMS first, increasing millisecond counter. Wraps around. Alright, so alright, so we just have to remember that those values are in milliseconds. And let's go ahead and run this. Oh no, wait, we're gonna do that. Yeah, I think I need to restart it. Let's see. Go ahead and unplug it. I don't think that's the right one, is it? It's gonna be that one. ACM10? No. Maybe 3, right? Ah. switch test 2930. Connect isn't defined. Oh, I'm so dumb. Okay, here we go. No lyrics. Alright. Wish there's an instrumental option on this on Chill Hop. Save that. You're gonna make me reload it, aren't you? Alright, here I'll just soft reload. Oh, see, this is what the hell happens every time I do like this off reload. It's all freaking weird on me. Alright, so I reset it. Oops. What? Is that not it? Yeah, TTY ACM3. Maybe it was already connected and I just interrupted it. No? Ooh. Bruh. Okay, wrong port. Here, work out or throw errors. 9 milliseconds, huh? That's what it took. But my light is still on. I think these all need to... I think I need to have the ground running into the... Maybe? I don't know. Let's see. Do I have another? I'll just get another jumper wire. I'm gonna burn something out, right? Wow, okay, so that ends up, it's actually no bueno. It does not like that. There's something about not doing that, I think. Yeah, don't power externally, use internal power rails. Okay. Ooh, spicy. It's hot. Yeah, I don't think you're supposed to do that. Shh. I think maybe that's where I kind of need like a shunt resistor or something. The wires go into the board, maybe? Or, no. That's probably a bad idea too. Alright, well I'm gonna let the thing cool off for a second because I think I kind of spiced it up with that. I'm gonna take a break really quick. And I will be back in a few minutes. I get some more water and go to the bathroom. You know, typical stuff. Typical human needs. Alright, be right back in a few minutes. Hello, hello. Is this thing on? Alright, let's see how spicy this thing is. I'm gonna plug back up. Boop. Boop, boop, boop. Speaking of hot, my camera overheated too. Wow. Right, it's kind of toasty in here. Okay, so that's problematic because it ended up powering the board externally, which you're not supposed to do. So it got a little hot, which is not a big deal. It didn't burn itself out. Apparently, these things are pretty durable. So, what do I want to do now? How do I power this thing, or how do I do this without burning up the jump release? Like, I guess I need like a shunt resistor, right? Search Yahoo. Oh my god, I hate you, Chromium. What is a shunt resistor? But I guess that's not the thing, is like we wanna divert it to ground, which how does that work? Because if I have an external circuit, I'd have to like either have two separate grounds, one for the jumperless and then one for the external circuit, or I could bridge them? I don't know, that seems like trouble. Let's try it. Or let's power it from the jumperless itself. We won't use the external power supply. Let's use the jumperless power supply, and then we don't have to worry about it, because that's the recommended way to do it with the jumperless. So we have our power connectors. This is an absolute mess, by the way. Okay. Let's get the... No, right here. No, not back to normal. We need to go to this one. Third port? Okay, third port. So, what is it? DAC. set bottom rail. Oops. Can't remember which deck number that actually is. And we're going to set it to 5. It's 5 volts, right? So now this bottom rail is 5 volts. I'm going to go ahead and plug this into that. Wait a minute. What is it grounding on? Eh? What the fuck? Probably all going through the wall. That is very confusing. No? Okay, that's weird. I guess it is getting its ground through the wall. That's really interesting. I've got that hooked up to the scope probe, like the ground on the scope probe, instead of the ground on the jumperless, and that's providing a complete ground for. Wow, that's okay. All right, well, we'll just do it this way. Scope goes up to that. Now we're measuring this. That's our external circuit. This is what we're measuring. This is controlled by jumperless. Alright, we want to do that. How does that go into... Oh, I guess there's like a tiny amount of current running through it anyway. And I don't have those connected. It's 29. Let's see. No, 29 needs to be ground, sorry. It's gonna be 30, goes to bottom rail. I guess we'll just leave it like that, I'll flip it around. Our positive, 50 is gonna be, or 30 is gonna be our negative. Oops. Wait. Back to fun. There we go. We're not powering our thing yet, so connect 30 to E and D. Is that power? No, wait. I'm so confused. Getting 5 volts, like I want. Going to the circuit. And 30 is supposed to be connected to ground, right? Oh, actually, I need to disconnect it. I'm so stupid. Disconnect. 29 with all pins. 30 with all pins. There we go. Now we're reading low current. Or low voltage, I guess. So let's connect the pin 30 to bottom rail, right? That gives us 5 volts. And then that should turn it on. Okay, so that turns it on. So if you do import, it's gonna connect it. Let's go ahead and adjust this really quick. We're going to set these to disconnects. We want to disconnect A and B from all pins. And then we want to connect A to bottom rail. And then we'll move these timing bits, but I think and we'll want to connect B to the ground. I think that's right. Yeah. That's our external circuit. And then what we want to do is let's move all this junk here. Oops. Let's do this. Comes down over here. The door is set up. Oh, you have to connect these all together, right? A to B. So J dot comma B. Oops. So used to using Sublime for my IDE. Then we want to reconnect them, right? So we're going to disconnect it and reconnect it really quick. We don't want to actually kill the device. We don't want it to stay off. Imagine this is going to go onto like a VCC line for something else, maybe. And then that's our finished and our elapsed. I think that's good enough to test with. Let's save it. Oh, jeez. Valid syntax line 1. What? What? I think you just can't connect to the damn thing. No. Ah! Okay. Switch test. Then we do switch test. And 29. Oops, 29. 30. Did that actually do anything? Huh? Did I disconnected A and B? Wait a minute. Get those? Oh, it isn't. That's what it is. Get state. Oops. Unicode error. Nice. No, wait. I don't even have to do that. I have to do JFS dot write. I promise I will remember this stuff at some point. JFS open. Oops. F equals JFS open. How do I have to do this? Wait, can I just look at the... Oh. Probably better. What is it? Get state? Interesting. Oops. Maybe it's the directory. Yeah, there we go. Yeah, right. And then F dot close. So then if we go into here, we refresh this, right? And then we've got nodes.json. Alright. Okay. So bottom rail is connected to 29, as it says. Ground is connected to 30. I think that's all I need though, in order to get the light running, so that's my problem. I don't know why it's only obvious when I look at it like that. So I guess I really just need to disconnect B from ground. Oops. Dummy. I think what I gotta do is reload that. Hard reset. That one? No. That one. Got it. Bottom rail isn't defined. What? Oh, running into all the problems, man. Okay, well, I turned it off. See? No? Yeah. Yeah, it doesn't really like it. I like actually getting it to reload libraries or imports or something. Kind of weird. Guess what I can do is make the boot.py and then just do this. File saved, and then when I reboot it, it should be fine. Ground isn't fine. What the hell? Oh, I'm so dumb. Alright, well, let's test and see if the boot.py works, because we'll have to. Yay, that's typing. It didn't bring it back up, though. Why did it not bring it back up? Oh, no, wait, it did bring it back up, but it's not, disconnect, connect. Oh, it's because A and B are connected? Yeah, it's because A and B are connected. I need to take this out. I wonder if you can, I wonder if there's like a speed difference between switching the DAC to 0 or something. Maybe you can do like, you can just control the supply voltage. I don't know. Might be different because if you're testing on the board, you kind of want to like power it from its normal power source. But I feel like maybe you could bodge the jumperless's power supply onto that board. Wonder if you'd have to worry about like large amount of current or something. Maybe if you like pulled the chip off the board, it wouldn't be a crazy bad issue, crazy big issue. So now we can specify our VCC from the command line, switch test. And then we set our DAC to that VCC. Oops. Let's see. We've got connect to the DAC, connect to ground. Everything is set up at this point, so hit timers and start. Maybe you need to do like disconnect A from DAC 0, right? I wonder if there's like a difference in the way that it looks up on the way that it shows up on the waveform. So that's what I want to look at next, is how fast this is. Disconnect, connect, let's go. A to DAC. And we'll save that, and most assuredly there are errors, but that is okay. Let's reset the machine. We'll reconnect to the device. Is that one? No. That one. Holy crap. I could just pull something up to look at that, but lazy. I wonder why it's not on right now. Okay, so let's go ahead and set our trigger to, bring this in a little bit, and we'll set our trigger, set it to single to capture just one doohickey. And then I'm gonna run this code again. Oop. Okay. And it says it took, what, 13 milliseconds? I need to capture that way too long. Let's see. Amount to like 1 millisecond, right? Let's look at it. Set it to single. Capture it one more time. Okay. Yeah, so this is about 20 nanoseconds. Wait, is that nanoseconds or micros? What was I reading? The micropath on time related functions, whatever. Milliseconds. Okay, well anyway, that's pretty quick, right? Can we, I don't know, is that waveform right? Am I doing this wrong? Who the fuck knows? Because what I'm doing is I'm dropping the power supply. And then it... Can I catch the before? Okay, hold on. There it is. That's what I was looking for. I was looking for the drop, right? That's interesting. So there's actually two of them. So there's two dips occurring. And they're lasting, let's see, we can measure it. This is 5 milliseconds. So 10 milliseconds. And then the code says 12. So, I mean, that's kind of on point, right? So let's do, is it fast disconnect, fast connect? Excuse me. Alright, we'll come back out to... I have it at 100 milliseconds. And... this going again. Alright, so that turns it on. It's on. That says it took 9 milliseconds to do that with fast connect instead of 12, right? And let's hit it with the scope. And we will zoom in, check that out. So it looks like 5 milliseconds. Yeah, that's like a whole 10 milliseconds again, or 8 milliseconds. Wait a minute. So the one on the right, it looks like it's 8 milliseconds, but the one on the left... So it's faster to connect than it is to disconnect, it looks like. Or not? I don't know. I wonder if it's better to, instead of run all the power through this, I can have... Maybe I'll take like a second wire. Let's do this. We'll take this second wire. And I've got another one right. I don't want to tear this one. Here we go. So do the second wire right here. We'll bring it over here and stick it 28. Oh wait. Okay, this will just be normal ground. That'll power the circuit, and then we'll stick that in, which goes to ground apparently. And then if we connect 30 to G and D, let's capture another single. Oh, bring this back out. Oh. And then we'll capture another single, or not. Hello? Oh, there it is. What the hell? Okay. Capture a single. Connect that to ground, right? Huh. That's much faster. Let's try, see if I can capture that now. Ooh, there we go. No, it's about the same, 8 milliseconds. Okay. 8 milliseconds might be a little too slow, so that might mean that we need to do actual crowbar circuit with a MOSFET. Which is okay, that's fine. Where are we at? Cat, what are you doing? Stop. He's attacking my 3D printed waste. Okay, is it this guy? Nope. Nope. This guy. So we need to get a MOSFET. I think I have one. I have a box of parts. Here's an N MOSFET. And then I think we have some other ones. It might be more suitable. I don't know. I truly do not know. These guys are old though, and they're big. It might be for like higher power switching or something. Probably use like a transistor if you wanted to do it too. Like a non-MOSFET maybe? I don't know. NPN transistor. Probably still be faster than 8 milliseconds. I guess the question is that if it, wonder where the delay is in calling this code. Because it may be 8 milliseconds from start to finish, but where's that 8 milliseconds coming from? I could try my next idea, which is changing the DAC, right? So I can take this and plug it in right here, and I can go set, or let's see, DAC set 0 to 0, and then we'll go DAC set 0 to 5 volts. And I don't even know if that actually causes the, and I can't see anything. Is it actually doing something? Maybe it is actually faster to do that. Nope. Okay. They're not actually changing the deck? Let's see. I guess it's bottom. That's it. I'm not. Wait, no. Is it deck? Yeah, it's bottom rail. That's why I'm so dumb. Not changing anything. I mean, it's changing something, just not the bottom rail. Bottom rail is which one? 4. 3. 3 is bottom rail. There we go. That's much faster, I think. We're down in the... No, actually it could be, just this slow. Let's capture it. See what it is. And actually, let's get the measurements on here so we can get the width, right? I don't know how that works. We're down to 500 microseconds. A little over 500 microseconds, so that's actually much faster to just change the DAC speed. So that could be our little blip, right? You like supplant the voltage for a thingy and then blip that to 0. You could even vary it too, which I was reading some research was suggesting that you could find like the minimum current or minimum voltage required to operate the device. What do you want? Kitty cat. You could find the minimum voltage required to operate the device and flip back and forth between that, and then that could be potentially useful to mess with some circuits or mess with some chips. Hello, yes. Hello, kitty. Hi. Do you want to sit in my lap? No. So that's cool. Alright, what do I want to do with that? So now that I know that's probably the way to do it, what we'll do is Let's make a new function. And how do we want to wire this? I guess the question is like finding the VCC pins on whatever it is and then dumping the voltage on that to nothing. It's a little tricky. Maybe that is where we need the MOSFET. Hello, yes, I know you're super cute. Uh-huh. What, are you hungry? I wonder if we can control it with this little MOSFET. Let's see if that's any faster. Or we could just write our code and start trying to glitch something. I think we should just write our code and start trying to glitch something with that, right? Should we have it set up so that there are pins on here that we use instead of just plugging them straight into that? I think that's better. I think that's better because what I can do is I can take this and this ground. Let's disconnect 29 from everything. And we'll do the same thing for 30. And we will, let's do this with our DAC 0, right? Then we can connect 29 to DAC 0. And then we can connect 30 to ground. That'll get it turned on. And then when we come over here, when we do this again, we can still get that as a thingy, right? Right now we're hooked into the back end DAC. That way our Rails won't actually... Okay, cool. Yeah, and that still captures... How do I measure this? I want to measure the... Oh, that's what I'm doing. I need to measure the negative width. Yeah, look at that. 700 microseconds. Let's see. What is it? Measure... Clear... Is it item 3? Item 2. There we go. Yeah, so 700 microseconds, that's the fastest. I wonder if we can test this too and see how long it takes for it in the code to register. So we'll still use DAC 0, we'll disconnect A and B, connect that, and then instead of using fast disconnect, we will do DAC set DAC to 0. And we will copy that. Oops. What the fuck is wrong with you? Okay. And then set that back to 5. And we'll use that as our measurement, or our action to measure. And let's go ahead and restart the jumper list. I think we're getting pretty close. I think that's That's pretty fast. 700 microseconds is pretty fast. Microseconds? Nanoseconds? What? Milliseconds? Might need to do microseconds, because it's probably just going to show 1 millisecond, right? Maybe it'll show more. We'll see. Get this reconnected to that. And we'll do switch, test, 2930. There's 3, right? Let's capture another one. Huh. That is not the same at all. I mean, is it? Okay, hold on. So maybe that's just it bringing it back high? No. Bring this out to, yeah, 50 milliseconds. We'll do a single capture again. Switch test. And then when we zoom in, there's actually 2 bumps in here. Why is that? Because I'm starting the timer right here. Probably even just do this. Timing's all fucked up. The code, the logic for that doesn't make any sense. I mean, it did. It was working, sort of, in a bad way. Okay, so this starts timing, or it gets a timestamp. Does DAC set, sets it to 0. Does DAC set, sets it to 0 again, or sets it back to 5. Then we get another timestamp for a finish. We get our lapse, and we print all of the timestamps out. We do all that in that order because we don't want to interfere with the cycles required to do that crap. Do that. Oh, you know what it is? It's catching this. It's catching this shit over here. So maybe we can do like let's find some pins, right? ECC pin equals 29, GND pin equals 30, and let's do target BCC or this BCC pin. And then what we can do is we can set these up where we go def setup let's just do setup. And what we'll do is we'll do basically all this shit over here. Hello, kitty. Yes, I know. I see you. You're adorable. And hungry and fat. What's up? Oh my god. You guys hear my cat? Going nuts. You're going nuts. What? Yes, I know. I know. Oh, nice. Yeah, buddy. You're rolling with globals. Globals up in here. Oh, gotta do that on our setup. And then we can run switch test. And that should make it so that we don't see this junk over here in the scope. So, go ahead and restart the jumper list. You see that comes back up. Connect to it. I can find the right ETY. Alright, cool. So let's go ahead and do switch test. See, that one said 1 millisecond, huh? Let's go ahead and do a single capture. Let's see if we can find it. Ooh, there we go. 652 microseconds. So that seems to be even faster. I don't know why, but cool. A 604 microseconds. That still may be too long. I don't know. I mean, we can try it. Another thing that we need to do is we need to conduct power analysis and see if we can measure the power over this trace. We also need to get data from the scope. Let's see if we can trigger this MOSFET and we can get it to actually do a bit better. So let's find out what this sucker is. Dude, is a 2N 7000, right? 2N 7000. So fast switching. Probably have to hop off here a bit. Getting hungry. But I think this might be what we want to use, and then we can just switch it to ground instead of changing the DAC. Maybe that'll be faster. No, because the switching was slow. Like actually connecting the bridges on those is slow. Maybe we could do that with the DAC and have that external. But realistically, it'd still be 600 microseconds or half that, right? I don't know. Because if it's half to turn it off, then it'd be another half to turn it back on. We can test that and see what that is. If we go back over to here and we do this. Comment that out. We want to time.sleep do. We'll just do a whole second, it doesn't matter. And what this will do is this will just turn it off. We can test turning it off, how fast it takes to turn it off, and then how fast it takes to turn it on. I want to see what the scope looks like with this. So go ahead and reboot that. Our setup. Let's grab a single. Switch. Test. 2930. Oh, I don't have to do that anymore. Just that. Elapsed in 0 milliseconds, huh? That's interesting. I don't think that proved useful. I think we're too close in. What the hell? Oh, I had it in single mode. I was like, where's my line? Where's my voltage line? I can't see it. Switch test. Hello? Oh, that was wonderful. Do I need to be measuring it over by the... by that? Does that actually make a difference? Wait, why would I want to do that? There's no potential between that. That's dumb. Okay. What about if we do that? Maybe it's catching like the beginning of it and not all the way down at the bottom? Oh, I'm dumb. It's because it's only catching like the off. Like how long it takes to go off, because I'm delaying the on time. So in this case, it's only taking, let's see if we can catch the rise time with this measurement. It says the rise time is about 3.94 milliseconds, or microseconds. That's a bit faster. Let's see if we can catch the rise time. Wait, that's interesting, because I'm setting it to 0. Why is it the... Yeah, I probably just don't know enough about the scope. The trigger, oh, we want it on the downward slope. That's what it is. Okay. Oops. Slope. Put it on the downward slope. There we go. Instead of catching it on the upward slope. And now if we do this, I bet it works. Hey, there we go. Okay. If anything, this is making me a lot more valuable with my scope. So that's kind of cool. And we measure this. What do we do? No, I don't want rise time. Let's do fall time. 5.3 microseconds. So I guess I was catching it on the flip side too. If we go and do all of it, we have like this. That'll catch both of them. And we'll restart this. Oops. We'll do switch test. And let's change this back to rise, because then we can capture the what is it? Both the fall and the rise at that signal. And it's a single capture, and we'll run switch test. Oh, I probably need to bring it out some. 10 milliseconds? Oh. Can I set it to that? Is that better? I guess that's either of them. Right? What is sweep? Single, normal, auto. Oh, that's for when it's in, running mode, or normal, I guess? Who's normal? Does that update every time there's another one? Oh, it does. Okay, so I can just keep doing that. Wow, that's sick. Look at that. I'm learning how to use my scope. If I do that and then I come back over here and run it again, it grabs the uptime or the up thingamabobber. What if I want both though? I was trying to get both. I had both last time. Type, edge, pulse, slope, video, pattern, duration, timeout. What? A window? Oh shit. Oh, I don't want to do edge, I want to do pulse. Oh, this thing is so fiddly. Then I can do that, right? No? Ah, I just gotta bring it out some more. This says the width is 500 microseconds. Rise is 10 microseconds, fall is 10 microseconds, so it's about the same amount of time as the rise and the fall. Huh. Yeah, let's try with the transistor doohickey. See if that'll make it any faster. Probably will. I guess I should write some of this down, right? Switch test apply. Alright, so I think let's go ahead and let's figure out how we wire this thing up. This sucker. Alright, so we've got source, gate, and drain. Alright, bend those legs really quick, stick them in the breadboard. And how do we want to use this? We've got source, gate, and drain. Source needs to be this power right here. What we can do is we can take this, stick it right there, for your source, right? Ooh, that was weird. Give me a crazy waveform on that. Alright, so that's gonna be our source, and then our gate, and then drain. How did this guy have his hooked up? And the gate hooked up to the IC, right? Source and drain to the power rail and ground of the target device, right? Crowbar glitch. I guess you really only need one wire? Hold on. Oh no, these are all in the same ground. Let's look at just wiring. Yeah, so this device that they're using shares the same ground. I think. I don't know what this MOSFET is. .3 nanosecond precision. Powering the gate of the MOSFET, the power flows this flow chamber, disrupting the power of the chosen component. So let's go ahead and I think is it source gate and drain. So 2 gets controlled by our doohickey. Let's see, this is going to be... I'll use this one. So this will control our doohickey. There's going to be 27, right? And then let's go over here. Let's set up the crowbar. So I think what we want to do for a crowbar, we can... We're going to take our pin and we want to pulse the DAC, I think, to just open and close the gate, right? And that'll drain it. That'll send it to ground. So what do we need? We also need another wire really quick. So we can then... What are we doing? I thought I had another one. Alright, here we go. Grabbing another wire. So this doohickey, this one is going to go to the ground over here, like so. And that should give us control over that MOSFET. We can test that really quick. I think it might actually be a good idea to test that. Let's put it in auto. And then we can come over here to jump in this IDE and we'll do connect. What is this? 26? Let's do 25. Sorry, remember. 25. 25 to DAC 0. And then let's see if it's connect. One. Okay, so if we just want to do that, then let's... Here's our setup. Setup connects ACC and ground to that. Connect 25 to max 0. Okay. Switch test, import setup, new setup. No? What's going on? Is your shit not powered? Oh, our shit's not powered. That's right, okay. Another wire? So then what we do is we go from power rail to here, right? That should connect our shit? No. The power rail is going to 29. Right here, let's disconnect 29 from everything. And we will connect 29 to 0. Right, and that brings it up to what, 3 volts? There's a get that 0? Huh. Interesting. Oh. Oh. Wait a minute. No, that's right. It actually does something, I think. Let's see. Get that. See it kind of dip a little bit, but we're also like running 3.2 volts. Which I don't know. Is that just because our... How is this thing? I just pulled this out of a damn box, so... Freeze our drain. That's going to ground. Which is coincidentally going to that. And this is our voltage. Okay. This may be something that I have to run at like a higher voltage or something. Okay, static drain source on resistance, drain source on voltage. Typical is 0.6. Okay, so never mind. Max is 2.5. Oh, am I blowing the thing out? Am I overdoing it? Drain source voltage on. Wait, VES. I don't like the gate, right? 8 threshold voltage, typical 1, max is 3. Yeah, I'm blowing this bitch out. Alright. Hey, what's up, Xer Sirens? How's it going? Probably a blue LED is not a good choice here. A bit higher voltage. Yeah. LEDs somewhere. Oh, I have one on the board right here. Good doing. Oops. Ah. No. Am I not even powering this portion of the circuit, or what? Hit deck 0. That's 3 volts. I mean, I am. I'm measuring 2 volts coming out of it. Let's check this. Maybe we can look at this with the, woo! Capture one of these and see what the on-off time of this thing is. I see, I don't even know if that's like, it's not even really like turning it off. Oh, there it is, never mind. No? It's only dropping it to 1.8 volts. I mean, that is pretty fast. 19 nanoseconds. I wonder what recommended MOSFETs are for voltage crowbars. Recommended MOSFET for voltage crowbar. High current, low resistance, in-channel logic level MOSFETs. That's the AI overview. Let's see if we can find out. There's a particular MOSFET that's the only real solution for speed here is to move over to an RTOS-based solution for controlling pulses and using solid-state components like a MOSFET to send power glitching pulses. Okay, well... No, Medium, I don't want to make an account. I refuse. Let's see. So I don't have expensive hardware like the Chip Whisperer. I have other expensive hardware. I want to try and emulate what they're doing, essentially. CW305. Oh, that's the Chip Whisperer 305. Power MOSFET. Okay, that's fine. One of the things that I wanted to do, I don't think this MOSFET's gonna work because it's 3 volts. At least not for what I need. I think this thing runs on 5 volts or something. Maybe I've got other MOSFETs that'll do the trick. We can go part hunting. Hello, Dawoot. How do you? So I've got like these. I don't know what these are though. Got them out of a grab bag. Box of random parts. The BUZ11? Like, what are these? Oh, hey, that's nice. I'm glad YouTube's actually recommending my channel. And good to know that this is interesting stuff for somebody other than me. Alright, so what is this thing? This is a BUZ11? ST Electronics BUZ11. In-channel power MOSFET designed for high-speed switching applications. 50 volt drain source voltage, 30 amps, blah 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 blah. Low on resistance of 0.04 ohms. So this might be what we want. We could see if this is fast. This is probably honestly faster than the little doohickey that I've got. And it's not necessarily speed. I need something higher voltage because that thing only seems to be 8 threshold. Minimum is 2, typical is 3, max is 4. 8 source leakage, turn on delay time. 45 nanoseconds, typical is 30. I mean, that's fast. That's faster than me. Yeah, go for it. You're more than welcome to. I need to actually set up a Mastodon. I'm typically on Blue Sky, but I know there's a lot of InfoSec and security and tech people that hang out on Mastodon. I just haven't bothered to set up anything yet. New source to drain current. Alright, let's just test it. Let's just mess with it. I'm in the mood to actually poke at stuff. I learn better with practice. That's why I'm doing this. Let's go ahead and stick this sucker in. Wait. We've got source on the left, drain, and gate. So this is actually wired differently. That's funny. Okay, so the drain is in the middle. Right there. You drain like that. And gate is over here on the right. We'll do source right here on the... Okay, that'll be better. I like that better. Move all that. Move this. And now we can hook this up. Oh, is it like this? Gate is on the left. Source is on the right. Drain is in the middle. Oh, that barely fits. And it goes off. I don't want it to go off though. Let me check my code. It's 3 volts. Let me set DAC to 5 volts. And then that brings us up. Let's see. We're at 3 volts. It shouldn't be doing anything though. I feel like it's not doing what it's supposed to be doing. We've got this going to power. That's going to... Go back to this guy's diagram. Their explanation. Connect the source and drain to the power rail and the ground of the target device. So this is... Oh, I guess I need to have it... I need to have my connection actually going before that one. So we actually need to do this. We can go back to this, where we've got... What was it? Check my ports, or my pins. First, drain and gate. Gate's going all the way over here. Wait. No, I got that backwards, of course. Typical. This blue one, that is our drain. That's right in the... Oh, I need to shift it over. Drain is right in the middle. Purple one is our gate. Yes, purple one is our gate. And then our source is going to be... Let's actually move this up a little bit so that we can then take this. So here's our source. And I know this is probably hard to see, but we'll do that. And then our source for this sucker right here. Actually, yeah, do that. Wait a minute. Yeah. You move this over here. Move my light over to the middle. Wait, do I? No. I don't think I needed to do that. Let's do this. Basically, I'm just trying to wire this into a circuit that I've got. I've got a little LED light going, and normally you'd put this on like a microcontroller, but I'm just testing to see if I can control it via the jumperless, and then write like a little library where I can do some voltage glitching with the jumperless itself. Because right now this external circuit's being powered off the jumperless, and I guess the idea is that if you just put some components like a microcontroller on the jumperless, you can then run some code to do some voltage glitching against it. Let's see. So I don't think I have this wired up correctly though. Did I get this backwards? Yes. Well, it's actually not, not like it's powering the circuit at all. I don't know. How long have we been streaming? 3.5 hours. I think this is a good stopping point. I've made some progress on testing these switches. I'd like to test this MOSFET a little bit more and see if we can get that set up with some code. Fill out this crowbar function and then actually do some voltage glitching. on this thing particularly, because I have a UART out on this, and I just kind of want to observe the UART and see if it does anything. Do some voltage glitches on it and see if the UART does anything, and maybe we'll get something fun from it. But I think I'll save that for tomorrow. Because I gotta hop off and get some food. And my husband just got home from work, so spend some time with him. Thanks for everyone that was hanging out and watching. I hope you had fun. If you want, check me out on my socials. You guys know the drill. There's a description. It's got all kinds of links and stuff in there. Yeah, shout out to the supporters on Patreon and YouTube members. And with that, you guys have a good night. Bye!